Okay, so today we're gonna do 4.5 and 4.7, but I was mentioning to one of the students, we're gonna start off with 4.5, then I'm gonna stop the recording, and then when we start 4.7, I'll start the recording for 4.7. That way, you guys can have them on Canvas by topic and not by by section and not by class session. Does that make sense? Okay, so let's get to this. The first thing that we're going to do in 4.5 is we're going to learn how to graph without a calculator. You guys are lucking out in terms of you're going to be able to use your calculator because we're probably going to have this exam online, and that's okay. It is what it is, but these are the steps that we're going to take in order to be able to graph this way. And so I encourage you guys to actually try to do it this way when you guys are doing your assignments. So these are the things that each problem that we're going to do are going to involve. So they're going to involve all of these 8 steps, okay? And so I'm going to do 2 examples. I know I have 3 on there, but I'm only going to do 2 of them. You guys can try to do the steps on the 3rd one, and if you'd like, I can send a response to all of you so you guys can see what that work looks like. But these are the steps that we're going to take. So in order to do this first problem, we need to be able to find the domain, get the intercepts, find the symmetry, asymptotes, the intervals of increasing and decreasing, where we have our local max and mins, the concavity and points of inflection, and then finally the sketch. So in the first 4 sections, we did A through G. Now, really what 4.5 is taking all that information to do H. Okay, so it's really not too bad, but it does involve some work. So let's go ahead and do this. So in this example that we have here, our part A is first to find the domain. And so we can see that the domain for this guy is going to be found by finding out where we have issues with our domain. And so to find the issues on the domain on this, it's not going to be in the numerator that we're going to have to look, but we're going to have to look at the denominator. So there's no issues, there's no restrictions with the numerator. So looking at the denominator, we're going to look at this, and we know that the denominator will not be able to equal 0. And so that's factorable because it's a difference of squares. And so because it's factorable, we can set each part of the factor equal to 0 or not equal to 0. And so x minus 1 is not equal to 0, and x plus 1 is not equal to 0. So then x cannot equal 1, and x cannot equal negative 1. So the domain to this thing is going to be all reals except x cannot equal plus or minus 1. Now, on WebAssign, it's probably going to ask you to do it in interval notation. So if we did it in interval notation, it would be from negative infinity to negative 1, union from negative 1 to 1, union from 1 to positive infinity. And these would all be in parentheses because we're not going to be able to include any of these endpoints. Are we okay with that? Okay. Thank you guys for replying. Now for part B, we're going to have to find the intercepts. And so to find the intercepts, we really are going back to algebra 2, right? And algebra 1. So to find the x-intercept and y-intercept, to find the x-intercept, we need to remember that we set y equal to 0, and then we try to find x. x, right? So if we set y equal to 0, the only possibility for this to be 0 is when the numerator is equal to 0, correct? So then 2x squared is equal to 0, so that means x has to be equal to 0. So we're going to get 2x squared is equal to 0, so then we see x is equal to 0. So our intercept is going to be at 0, 0, right? For the y-intercept, we're going to set x equal to 0. And since x is equal to 0, we can see that the y-intercept clearly here has to be 0, right? So y is equal to 0. So the x and y-intercept occur at one point. That's going to occur at 0, 0. All right, so let me just start setting this up so we can see. So we know that there's going to be the intercept right there. Just trying to put some points to it. Okay, now for part C, we're going to try to find symmetry, right? And to find symmetry, I don't know if you guys remember symmetry, but there's two ways to do it, to find even or odd. So if f of negative x is equal to the actual function, this means we have an even function. If f of negative x is equal to negative f of the function, right? Negative the function, then that is odd. If we don't have either one of those, it's a neither case. Does that make sense? All right, so then what we're going to do from there is we're going to plug into our function. And so I'm really going to make this is going to be f of x is equal to 2x squared over x squared minus 1. So then if we do this, we're going to get f of negative x is going to be equal to 2 times negative x squared over negative x squared minus 1. And that's going to give me 2x squared over x squared minus 1. And that is equal to f of x. And so since this is equal to f of x, we have an even function. So since it's even here, we know that this thing is going to be symmetric about the y-axis, right? If it's odd, it's symmetric about the y equals x-axis, or y equals x line. But I'll show that to you guys as we go through this thing. Now to find the asymptotes, this involves a bit of work, but we can do that. Remembering to find asymptotes, to find horizontal asymptotes, we're going to go to infinity, right? So trying to remember from chapter 2, to find horizontal asymptotes, we're going to go the limit as x goes to, let's say, positive infinity of 2x squared over x squared minus 1. And this thing is infinity over infinity, right? And since it's infinity over infinity, we get a trick. We get to use L'Hopital's rule. And so the limit as x goes to infinity, we're going to get 4x over 2x. But isn't that again infinity over infinity? And since that's infinity over infinity, again we can use L'Hopital, and we're going to get the limit as x goes to infinity of 4 over 2, which will simply be 2. And so now we see that we have a horizontal asymptote as we go to the right of y equals 2. That's good enough. Doesn't have to be a perfect square. Okay, now we need to show it also going to the left end. So this was going to the right. Now we're going to show going to the left. Okay, now from the left, it's going to be the limit as x goes to negative infinity of 2x squared over x squared minus 1. And then again by L'Hopital, because it's going to be a negative infinity over a negative infinity, we're going to get the limit as x goes to negative infinity of 4x over 2x. And again by L'Hopital, we're going to get the limit as x goes to negative infinity of 4 over 2, which again is 2. So on the left, it will again be y equals 2. Any questions on the horizontal asymptote? No? Okay. All right, so what I'm going to do is I'm going to do my asymptotes in red. So if we're going to go y is 2, let me go in increments of halves. So this will be 2. Okay, so that will be 2. Now we need to find the vertical asymptotes, and so to find the vertical asymptotes, we can do that as well. To find the vertical asymptotes, we need to find where the denominator is equal to 0 and then set our limit equal to that. So we already did that. Up above, we found that x in the domain, when we looked at the domain, that x couldn't be 1 or negative 1. So we're going to look at both of those limits, okay? So now for vertical asymptotes, what we're going to get is the limit as x approaches negative 1, and we're going to take negative 1 from the right? Because we want a one-sided limit of our function, and our function is going to be 2x squared over x squared minus 1, and that's going to give me, if I'm going to, from the right hand side, then as I'm coming to that value, I'm going to get I'm going to get a 2 on top, but that negative 1, if it's coming from the right, isn't that a value like negative 0.9, right? Because it's closer to 0. So if I put negative 0.9 into the x squared piece, I'm going to get 0.81 minus 1, and that's going to give me a negative number. So I'm going to end up with negative infinity. Are you guys okay with that? Is there anyone that has a question on that? Because I just want to make sure that you guys are able to get that and understand. Sure. So since I'm going from, let's see if we had a number line, right? And this was negative 1. I'm coming to the negative 1 from this direction, right? So I'm going to pick a number like negative 0.9, because that's actually closer to 0, right? As an example number to use that's close to negative 1. Now, when I do that, if I plug in that number, don't I get 2 times 0.9, negative 0.9, but it's squared, over negative 0.9 squared minus 1. Well, the top is going to be a positive number, right? It's going to be a positive 1.8, right? And the bottom is going to be a negative, it's going to be 0.81 minus 1, which is going to give me 1.8 positive over a negative 0.19, correct? So what this is showing me is this number is going to keep getting bigger. This number is going to keep getting, so this one's going to get bigger. This one's going to get smaller. And so when we divide, or let's say even the top just stays the same. Let's just say the top were to stay the same just for simplicity's sake. The bottom for sure is going to get smaller and smaller and smaller, right? So as we have a number, like let's say 10 divided by 1, you're going to get 10. But then 10 divided by 0.5 is 20. And then 10 divided by 0.25 is 40. And so you see what's happening is this thing is going to get bigger and bigger and bigger and eventually go to infinity. But because they have different signs, it's going to go to negative infinity. Does that make sense? Okay, yeah. So that's how I'm doing it. I'm using small examples to make generally like a general rule. Okay. So since this thing goes to infinity, that's one of the qualifications for a vertical asymptote. And so I know that I have a vertical asymptote at x equals a -1. Okay? Now, by that same reasoning, I'm going to use the limit as x goes to 1. And I'm also going to go from the right here. And doing the same thing that I did, I'm going to get positive infinity as an answer for this one. And so I know I have a vertical asymptote at x equals 1. Okay? And by the same reasoning, since I'm coming from the right, I would pick a number like 1.1 because that's to the right of 1. Does that make sense? Yeah? Okay, so then let me put the two vertical asymptotes up. So here is this one. Again, I'm going in increments of a half on my graph, so you guys can see. And so we are already being able to see some stuff, right? Okay, something cool. From these two answers here that we got, I can actually show you something cool. So if I come to 1 from the right, it said it was positive infinity. So I know this thing's coming from up here. Does that make sense? Are you guys okay with that piece? I'm using the vertical asymptote limit to be able to tell me something about what's going on there. Okay, and then I also knew from the -1 that this one's going to negative infinity over here. So that tells me that this thing for sure is going to go this way. Okay, I'm just using the data to be able to build my graph. Okay, now I'm going to use increasing, decreasing things to be able to see if I can find even more information. Okay, so now I'm going to go, the next piece was to find intervals of increasing and decreasing. So now let's do part E. And I think this will be able to help us do some things. Now, remember one thing too that's important. Since this thing is even, I should be able to fold it at the y-axis. And so since that's true, I already know that this is going to go this way, correct? And I also know that this guy's going to have this value up here because I can fold it over on itself. That's what even helps me do. Does that make sense? Okay, cool. Now, let's find the increments of increasing and decreasing. And so when I take the derivative, don't I get 4x times x squared minus 1 minus 2x squared times 2x all over x squared minus 1, that quantity squared, correct? And so when I clean that up, aren't I going to get a negative 4x over x squared minus 1, that quantity squared? Please do me a favor. I'll give you guys a second to verify that. But I want to make sure that you guys actually see that. Okay, did you guys get it? Cool. Okay, so now we need to test the critical points on this thing, right? So when we test it, because we need to be able to test, we see that -1 and 1 are critical points because they make the denominator undefined. And 0 is a critical point because it makes the whole derivative equal to 0, right? So then one of the things that we see as we plug into the function, if we plug in a value like -2 into it, that thing's going to give us a positive. If we plug in a -1/2, that's going to give me a positive. And then when I plug in 1/2, I'm going to get a negative, and when I plug in 2, I'm going to get a negative. So what this is telling me is that I'm increasing from -infinity to -1 union with -1 to 0, right? And I'm decreasing from 0 to 1 union with 1 to positive infinity. Okay, now when we have this piece here, what this is telling us is something very, very cool. I already have enough to be able to graph this function, but let's see if we can confirm what we've gotten so far. I'm going to use I'll use orange to show you guys this. Look what's happening from -1 to 0, right? From -1 to 0, it's increasing. So it's saying that I should be going up in value on this side. Is it doing that? Right? Clearly we can see it's going up in value on that side. Okay. From 0 to -1, it's dropping in value, right? It says it's decreasing. Is it doing that? We can see that there too, right? Now, it tells me that from -infinity to infinity, it's going to be increasing. So that's cool. It should be getting a value that's higher and higher and higher, right? And then from 1 to positive infinity, it should be dropping in value. So we can already tell a lot from there. Let me go ahead and take the part G piece so we can find concavity, and we can go from there and complete this thing, which will be cool. Some of the things that we also should be able to tell, do we have any max or mins? Since it's an open interval, we do have a local max. And where is that local max? Yes, it's at the origin, but when we talk about ats, we talk about x. So it is at x equals 0, right? It's at x equals 0. So that's important. We got that. Okay, let's check the second derivative. And so when we take the second derivative, I'm going to get y double prime is going to be equal to a -4 x squared minus 1 squared plus 4x times 2x squared minus 1 times 2x all over x squared minus 1 to the 4th. And then that should clean up to be 12x squared plus 4 over x squared minus 1 to the 3rd. Go ahead and take a second to verify that for me, and then let me know if you get it. Okay. Now I'm going to find the zeros for this thing. And what's cool is the only zeros that we have, because the numerator can't be 0, are going to be the critical points that we had from before. So it's going to be -1, 0, and 1. It's a negative there. Just want to make sure you get that. And so when I plug in values, if I plug in a -2, I'm going to get a positive. I plug in a -0.5, I'm going to get a negative. A half will give me a negative, and a 2 will give me a positive there. So what this is telling me is I'm concave up from -infinity to -1, union with 1 to positive infinity. And I could have just put infinity. I don't know why I put the positive. And then concave down from -1 to 0, union 0 to 1. And I can't put from -1 to 1 because remember 0 is a 0 slope. It has no concavity there, right? So do we have points of inflection? That's something that's important. Remember, points of inflection are where it changes from positive to negative or from negative to positive. Do we have those? Okay, the answer is no. There is no point of inflection in this problem. And the reason why there is no point of inflection is because at -1 and 1 we have vertical asymptotes. And since we have vertical asymptotes there, we can't have a point of inflection. Now, one of the things that is cool though is since we know concavity is up from negative infinity to 1, this thing is increasing in value and concave up. You guys follow me? It's increasing in value from part E, so it's going up in value. Part G is telling me it's concave up, so it's got to be turned up like that. I see that we have negative infinity, or we have negative values or concave down from -1 to 1. So it's like a parabola turned upside down. Is that what we have from -1 to 1? Clearly we see it does. And then it's going to be concave up, again, from 1 to infinity, but it's decreasing in value, and so the graph will look like this. So by doing all of these processes, I was able to graph what the function looks like without a calculator. You guys see how fun this would have been for you? You guys are ecstatic, right? So on the exam, I'm not going to be able to do that to you guys, obviously, but you can see the process, and you guys can confirm this. Graph this function on your calculator, and you'll be able to see what's happening here. And you'll see that the picture does look like this. And I did it all by just doing calculus. So not too bad. All right, let me do the next example. And after I finish the next example, I'll stop the recording and switch over to record for my next, for 4.7. Now, we'll be completed with chapter 4. And so what's going to happen is we have spring break next week. We can do a review of some sort on the Tuesday with a small lesson for chapter 5. And then we'll take our test on that Thursday. Let me look and see what date that is. So we'll be taking an exam, it looks like April 2nd. Okay? Okay, so let me do the next example. And so here we go. So going through each of the steps, the first thing that we need to do is find domain, right? So to get the domain of this guy, we need to find out what the restrictions are. There's no restriction. I don't know what I spelled there. That's crazy. There's no restriction on the numerator piece, but there is a restriction on the denominator piece. And so when we have a square root, and it's an even square root, it's got to be greater than or equal to 0, right? So then x plus 1 has to be greater than or equal to 0. But, and this is a big but, we can't have it be equal to 0 because it's in the denominator. Does that make sense? So we have to have x plus 1 is greater than 0. So x has to be greater than negative 1. So our domain will be from negative 1 to positive infinity. We okay with that? Okay. So then part B is to find the intercepts, and so the x-intercept and the y-intercept again can be found by setting the perspective things equal to 0. So this would be y is equal to 0. This is going to be set x equal to 0. And so we see that we get 0, 0 here and 0, 0 here. How uneventful. So we know that there is an intercept here. Now, I'll do this for you guys in a bit. Now for symmetry, we're going to check f of negative x. And so when we do that, we're going to get negative x squared over square root of negative x plus 1. Well, that gives me x squared over square root of negative x plus 1. And so we have no symmetry, right? There is no symmetry there. And so we have nothing to worry about in terms of being symmetric at all. All right. Now, to find the horizontal on this guy, so we're looking for a horizontal asymptote. Something that's cool about this one is because x is restricted to being greater than negative 1, we don't have to take the limit going to negative infinity because it can't go to negative infinity. So the only limit that we need to take here is x going to positive infinity. And so we're going to get x squared over the root of x plus 1. And if you guys remember, if I divided top and bottom by x, right, I'm going to get, how do I want to do this? Do I want to divide by x so you guys can see it? I mean, I could do it that way. Oh, I don't want to divide by, I don't want to do it that way. What's going to end up happening here is we can look at these ratios. What's growing faster, x squared or the square root of x plus 1? I'm going to look at the growth rate, right? Because in this case, don't we get infinity over infinity? So I can go by L'Hopital, and I'm going to get the limit as x goes to infinity of 2x over 1 over 2 root of x plus 1. And really what ends up happening there is, don't I get the limit as x goes to infinity of 2x, well actually I'll call it 4x root of x plus 1. And so doesn't this just become infinity times infinity, which is infinity? I could have done L'Hopital to this too, but there's really no need. I can see that this thing is going to now take off to infinity. And so since this is taking off to infinity, the limit is equal to infinity. There is no horizontal asymptote, right? Because they would have to go to a specific number in order to be a horizontal. Okay, now for the vertical, where do we have our issue? Our issue is going to occur at x equals a negative 1. So then I'm going to take the limit as x goes to negative 1. And I'm going to go, let's just go from the right because we can't be from the left. And so I'm going to get x squared over square root of x plus 1. And that's going to give me a positive infinity. Okay? And the way I did that, again, is I picked a number like negative 0.9. And I could see that the numerator is going to be bigger as the denominator gets smaller, which means I'm going to get an infinite. Now, since it goes to infinity, that satisfies one of the 6 rules for vertical asymptotes. And so we have a vertical asymptote at x equals a negative 1. So now looking at our picture, I'll go by 2. This is a vertical asymptote here. And then I'm going to do this too, just so you guys know. None of this on this side can be part of the answer because our domain restricts it, right? So this is out. So there's no graph on that side. So I just wanted to make a visual that not only is it a vertical asymptote, it is a hard line. There's nothing on the other side. Okay? We also know that this is going to infinity up here, and this is 0, so this has to do something like this. Are you guys okay with that? And the reason I know that it was doing that is because the horizontal asymptote, the vertical asymptote tells me as I get close to negative 1, it was a positive infinity. Okay, so let's do part E. And in part E, it's taking the derivative of this function, and so what I'm going to get is 2x times the square root of x plus 1 minus x squared times 1 over 2 radical x plus 1 all over the square root of x plus 1 squared. And then that should clean up. I should have put f prime. So then f prime of x is going to be equal to x times 3x plus 4 over 2x plus 1 to the 3 halves. Okay, you guys can verify that. That's algebra. And then our critical numbers, that we're going to get, it's interesting. It's going to be negative 1. We have a negative 4/3 and 0. Now, what's interesting is that negative 4/3, is that relevant? It isn't going to matter, and the reason it doesn't matter is because it's out of our domain. So this is a false critical number, okay? So we only need to test between negative 1 and 0 and 0 to infinity. And so when I plug in values, I'm going to get a negative here and a positive here, right, by plugging into the derivative. And so I can see that it's decreasing from negative 1 to 0 and increasing from 0 to positive infinity. Okay, do we have a local max or min? What do you guys think? Do we have a local max or min? We have a local min. Where does that happen? Yeah, it's going to occur at 0. So at x equals 0 is our local minimum. Okay? All right. Now, for g, we need to take the second derivative of this thing. And this thing's quite ugly, but I'll do it. So we're going to get how do I want to do it so you guys can see it nice and pretty? All right. All right, I'll do it this way. I'm going to multiply in the x so that it's cleaner for me to look at. So I'm going to get x, 6x, 6x plus 4 times 2 times x plus 1 to the 3 halves. Do you guys see that? Then minus, I'm going to go 3x squared plus 4x, and then the derivative of the other piece, which is going to give me x plus 1 to the 1/2 power. And then make sure I got that right. The denominator will then be 4 times x plus 1 cubed. And let me see if I get this totally right. I think I may have left out a 3. Let me see the second piece. So if I get 3x squared plus 4x, and then the 3 halves comes down, I think 3 times x plus 1 to the 1/2 power. Yeah, I think I need a 3 there. Do you guys agree with that? Yeah, and all of that is equal to, oops, dang it. That's equal to f double prime of x. In fact, I can erase that. F double prime of x is equal to this. This is part G. And over the line. Okay? Now, from here, we need to see if we can clean this up. Let's see if we can clean this up. This is ugly. All right. Awesome. How do I want to do this? Okay, here's what I'm going to do. I'm going to clean it up by factoring things out. So this is going to, bear with me, it's going to be a little bit ugly, but we need to do it. So we can see that both sides have an x plus 1 in the numerator to the 1/2 power, right? So I'm going to go x plus 1 to the 1/2 power. And then that's going to give me 6x plus 4 times 2 times x plus 1, correct? Minus 3 times 3x squared plus 4x, and that's it, over the 4 times x plus 1 to the 3rd. I believe that's correct. Yeah. All right, so if I bring that down, don't I get 6x plus 4 times 2x plus 1 minus 9x squared minus 12x. And then this is going to be 4 times x plus 1 to the, that's going to be 6, so 5 over 2. And then expanding that, I'm going to get 12x squared plus 6x plus 8x plus 4 minus 9x squared minus 12x all over 4 times x plus 1 to the 5 halves. And that's going to give me 3x squared, 14 minus 12. 14 minus 12 is 2x plus 4 over 4 times x plus 1 to the 5 halves power. Correct? I think I did that math right. And so from here we can see, is it ever possible for this thing to be negative? Remembering that we have to be bigger than negative 1. The answer is no. So this is always positive, and since it's always positive, we know we're concave up where? Everywhere. Okay? Since we're concave up everywhere, and we can see it's increasing from 0 to infinity, doesn't this thing then do something like this? Right? I don't even really need values. You could find a point, but you can see that this thing is going to be taking off and looking something like this. All right? Does that make sense? You guys can see these problems are a little bit tedious. They really are. And they're a bit time consuming. The first and second derivatives can be crazy, but yeah, they're doable. The key to all of this is making sure that you test them, right? We're going to be testing them to check to see that they're working. We're going to find increasing, decreasing. We're going to try to find the local min and max, checking for the concavity. There's so much that we can do with these problems. Okay? This is 4-5. I'm going to go ahead and stop the recording here, and then I'll start a recording for 4-7. I'll give you guys a 5-minute break to go use your restrooms or do whatever you want, or just to walk around and give myself a chance to kind of stretch. So I'll get up. I'm going to stop now.